Working with radians. What are radians? What are radians? Radians are another way that can be used to measure angles when working with circles. We've all used degrees, but now we're going to do the same thing only in radians. A radian then is the measure of an angle formed where the radius measure, which is the length from the center of the circle to the outside of the circle, is equal to the arc length. This was discussed in the last video. We can do a conversion factor and find that 1 radian is approximately equal to 57.2958 degrees. The arc length, this is a formula that you need to make note of. The arc length is equal to the radius times the number of radians. The radius is equal to the arc length divided by the number of radians. And the number of radians is equal to the arc length divided by radius. These three formulas are very important when you are answering the Lesson 1 assignment. Here is an example. Priya wants to ride a carousel. The horse that she wishes to ride is located 9 meters from the center of the carousel. If the carousel turns through an angle of 5 pi divided by 6, determine the length of the arc traveled by the horse to the nearest tenth of a meter. Now, let's look at the solution. First of all, we will carefully read the question, identifying key pieces of information given that we will need for our calculation. Priya wants to ride a carousel. Nothing there. The horse that she wishes to ride is located 9 meters from the center of the carousel. Clue. That provides us with the measure of the radius. If the carousel turns through an angle of 5 pi over 6, another clue because it's giving us the angle. Determine the length of the arc, another clue, because that tells us what we are going to look for or calculate, travels by the horse to the nearest tenth of a meter. Now that we've read the question and analyzed it, we can select the correct relationship to use. We know we're trying to find arc length, which is equal to the radius times the number of radians. Example 1 continued. Substitute the values from step 3 into the formula from step 1 and 2 and calculate the answer. So arc length equals radius times number of radians. Radius is 9. Number of radians is 5 pi over 6. Multiply the top, 9 times 5 pi, divide by 6. Common factor out 3. So 3 times 5 is pi, and 3 times 2 is 6. So our answer would be 2. Write your conclusion. The length of the arc, distance the horse traveled, is 15 pi over 2 radians in exact form. Now, let's talk about angular velocity. The angular velocity of a rotating object is the rate at which the central angle changes with respect to time. Here is an example of angular velocity. You can find angular velocity by calculating the number of revolutions divided by time. Depending on the wind conditions, the blades on a wind turbine turn at a rate of 20 revolutions per minute. Determine this angular velocity in radians per second. Write down the information given in the question. The revolutions per minute is 20. The number of seconds in 1 minute is 60. Substitute these values into the given equation. One rotation is 2 pi radians. 20 rotations would be 20 times 2 pi radians, which is 40 radians. Substitute these values into the given equation. Angular velocity equals the number of radians divided by time. We know the number of radians is 40 pi, and we know the time is 60 seconds. So, doing the math, simplify it to 2 pi over 3 radians per second. Now it's your turn. Complete lesson 1 assignment.